Okay, here's your super fast as I can make it, unit circle review. And the hard part is with the different methods that are out there, one of the pieces of the review is remember to draw your angle, and which quadrant it falls in tells you whether your answer should be positive or negative by your all students take calc. Okay. If you are a memorized quadrant 1 person, it goes small to big. So in degrees, that'd be 30, 45, 60. In radians, that'd be pi over 6, pi over 4, pi over 3. That your ordered pairs, and this goes for all of our ordered pairs that we ever see on the unit circle, go cosine, comma, sine. In memorized quadrant 1, we usually go 1, 2, 3, 1, 2, 3. So it's square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, 1 over 2, square root of 2 over 2, square root of 3 over 2. If you are a special right triangles person, you would draw your 2 special right triangles models with your hypotenuse being 1. So your 45, 45, 90, or pi over 4 would be a square root of 2 over 2, square root of 2 over 2. And your 30, 60, 90, with your hypotenuse being 1, your 30, across from your 30 would be 1/2, across from your 60 would be the square root of 3 over 2. Or if you're a hand trick, remember it goes cosine fingers, comma, sine fingers, square root of fingers over 2. Tangent is flip it to the back side, square root of fingers over square root of fingers. And that our axis, 0, 90, or pi over 2, pi, or 180, 270, or 3 pi over 2. And then I think about the ordered pair to get there, is that I would move to the right 1, up 0, right 0, up 1, left 1, up 0, right or left 0, down 1. And that all of our ordered pairs, whether it's in our first quadrant or on our axis, always go cosine, comma, sine, and tangent is sine over cosine. So as we started our unit circle questions, we always started by thinking about where is that angle. 30 degrees is in quadrant 1. As I think through my all students take calc, that means my answer is positive, because all things are positive. I go to my method, 30 degrees, first answer, 30 degrees adjacent over hypotenuse, my hand trick, 30 degrees is here. I have 3 cosine fingers, square root of 3 over 2. Same angle, different question. Sine of 30 degrees would be your second answer, or your opposite over hypotenuse, or bottom fingers over 2, 1/2. 60 degrees, here, cosine first answer, here, adjacent over hypotenuse, 60 degree reference angle, top fingers over 2, 1/2. Again, 60 degrees being in quadrant 1, all things positive. Moving to an axis, 90 degrees is here, cosine, comma, sine. So if they want the cosine, it is literally the first number sitting in that ordered pair, 0. Sine of 90, 1. Questions? We will continue to review unit circle as we move through today, because that is what's all based on. As I keep talking, make sure you also have your identity sheet out, because we are going to add to our identity sheet. We are transitioning into your sum and difference formulas today. What does the word sum mean? Difference, subtraction, right? And that's what you're going to do today, is you're going to add or subtract angles together strategically to be able to find some values. Okay, so let's go to your identity sheet. What you are looking at is what is called your cosine sum and difference formula. It's called sum or difference based off of, in the one where there's 2 angles inside the parentheses, whether it's a plus or a minus between them. If it's 2 angles added together inside of this cosine, your formula becomes cosine of whatever was written first times the cosine of whatever was given second, minus, and then the sine of each of those. Sine of the first angle, sine of the second angle. Your book and most places out there will use Greek letters like alpha and beta. If you want to change that into A and B, you are welcome to do that, or X and Y. I don't care what variables you use. The difference formula, again, said that originally I was subtracting two angles here. If that was the case, it would be equivalent to doing this. The cosine of what was listed first times the cosine of what was listed second plus the sine of what was listed first times the sine of what was listed second. And I'll show you how we are going to use these formulas here in just a second. Not ones we will ever have to memorize, just like before. Okay, we just have to know which one to pick and how to use that. Anyone still need this page? Okay, so let's look at an example. Had I handed you earlier today the question of cosine of 15 degrees, we would not have the ability to do that right now because 15 degrees is not on our unit circle, is it? We've got 30 degrees, we've got 45 degrees, we've got 60 degrees. We don't have 15, do we? But what we can do is use this sum or difference formula. And what I want you to do is think about your unit circle. Think about, I mean, it can be anywhere, but like if we were to think about quadrant one, and I'm going to look at quadrant one in terms of degrees here. This is like your word bank. Your unit circle is your word bank for these, and those are your options. And what you want to do is you want to find a combination of these numbers in which I can add or subtract them to get this number. And there is many, many, many ways of doing that, okay? Using our word bank in the first quadrant of 30, 45, and 60, give me an option of how I could get 15 degrees through addition or subtraction. 45 minus 30. Okay, what about 60 minus 45? Also 15. Both will get you the exact same answer. Okay, so you pick. But basically, we break this number on the inside into unit circle numbers added or subtracted together. So I could do, let's do 45 minus 30. Okay, as long as that sum or difference, and we're looking at a difference here, would still be 15, it's the same problem, right? They are equivalent. But now I can apply my difference formula. It is cosine. I have two angles, and the key is that it is a subtraction here. So if we were to go back to this last page, which you guys should have sitting in front of you on your identity sheet, we're looking at this one. It says cosine on the outside, and there's a subtraction between my two angles. And what that says is to take the cosine of the first angle, cosine of the second angle, plus the sine of the first, sine of the second. And that's what we'll do. Cosine of our first angle being 45 degrees, cosine of the second angle, which is 30, plus, because that's what our formula tells us to put there, sine of the first angle, sine of the second angle. Now I should have four little problems up there that are unit circle questions that I can do. Okay. Cosine of 45 degrees. And hopefully these will speed up because you're going to see a lot of the same ones over and over. What's cosine of 45 degrees? Square root of 2 over 2. Cosine of 30 degrees. Hand trick, or your square root of 3 over 2. Go to your first quadrant, whatever your method is. Consult it right now. Cosine of 30 degrees is square root of 3 over 2. Plus, and now we keep going, sine of 45 degrees. Square root of 2 over 2. Sine of 30 degrees. 1/2. Okay. Guys, there's only so many numbers on the unit circle. And as we are doing this, you're going to see the same answer like over and over and over because it's coming from your unit circle values, and those are all consistent all the way around your unit circle. So let's talk about algebra skills now. I have to simplify this. When I take a radical times a radical, multiplication wise, I can actually do that, right? Square root of 2 times square root of 3. I can multiply the inside times the inside and get the square root of 6. When we are multiplying fractions, we multiply straight across the top, straight across the bottom. So 2 times 2 is 4. Similarly, multiplying straight across the top, square root of 2 times 1, anything times 1 does not change. And 2 times 2 is 4. And now if I want to add or subtract fractions, I need a common denominator, which should happen at this point every time because they're coming from the same thing. And that common denominator is going to be the square root of 4. And what you're going to see that is going to look so the same every time, but with slightly different order and signs, is the numerator. Now, again, algebra conversation. I was able to multiply 2 radicals together. Can I add 2 radicals together that are not the same? No, those are not like terms. And so they just sit next to each other in the numerator. That would be fully simplified. Remember that I am not able to simplify like a square root of 6 over 4 because that's inside, that's outside. And they can't simplify together, right? Inside numbers with inside numbers, outside numbers with outside numbers. Questions? Okay, so we can find an exact value using kind of creativity here of how to get that number. Okay, so let's try another one. Cosine of 105 degrees. So what we need to do is now go to our unit circle. Now remember, your unit circle does not stop at quadrant 1, and this might be something that you want to have to look at is your unit circle. Okay, so in degrees, remember this goes 30, 45, 60, but it doesn't stop there. We've got more angles over here. And why do I say that? Because maybe we want to utilize some angles in quadrant 2, which would be, let's see, 120, 135, 150. We've got a 90 up here. We've got a 180. And that, again, this is my word bank, right? Pick 2 angles up there that when I add or subtract them would give me 105. Okay, so what do you think? 45 and 60, and that would be adding them together, right? Did anyone see one like that was subtracting? 135 minus 30. Would I get the same answer at the end? Absolutely. Okay, so I don't want you again to stress over how you break this. I'm going to go with the first one that was 60. What did you say? 60 plus 45? So that we can see a sum formula. And the last one we did a difference formula. Now we can see a sum formula. Okay, so again, we go to our identity sheet. I go find that formula for the sum cosine of a sum. And that formula says that we do the cosine of the first angle times the cosine of the second angle minus sine of the first angle times sine of the second angle. Now, just to maybe address out there, did anyone put 45 first and the 60 second? Maybe. Coming down here, would that change this answer? If I had the 45 first and the 60 second, it's multiplication at this point, and order will still give me the same answer, right? So I don't want you to stress over the fact that I put 60 plus 45 and you put 45 plus 60, and is it the same? Absolutely, it's the same, okay? And we'll have the same answer at the end. So this is, again, where we want to have our unit circle stuff like there for us, whether it's whatever our method is, and be able to do this part kind of quickly. Cosine of 60 degrees is 1/2. Are we okay to go that fast now at this point? Cosine of 45 degrees is the square root of 2 over 2. Sine of 60 degrees is the square root of 3 over 2. Sine of 45 degrees is the square root of 2 over 2. Guys, you are not going to get anything other than these numbers. The only variation is you might sometimes have negatives, but it's going to be the same fractions over and over and over. which is why our answers are going to look so similar every time. Signs then super matter. Okay. So multiply straight across the top, straight across the bottom, just like we did on the last page. We get square root of 2 over 4. Multiply straight across the top, straight across the bottom. Again, just like we did on the last page, we get square root of 6 over 4, which is square root of 2 minus the square root of 6 over 4. Now, depending on our order, could I possibly get that flipped? Yes, it is the same as a negative 6 square root of 6 plus square root of 2 over 4. And how do I check that? You check the sign. The sign in front of the square root of 6 needs to be the same, negative and negative. The sign in front of the square root of 2 needs to be the same, positive and positive. And if our order is backwards from each other, as long as our signs match, you're good. Questions? Okay. I think for time's sake, I won't do it, but could I have done this as 135 minus 30 and get the exact same answer at the end? Absolutely. Okay. Absolutely. You will get the same answer at the end. All right. Working backwards, continuing to focus on this whole cosine formula here. What I want you to notice is right now you're doing the matching game. Is this matching the cosine of a sum, or is this matching the cosine of a difference? How do I look? How do I find it? Notice that it goes cosine, cosine, sine, sine. So I know it's our cosine formulas, which you'll see later. And then the next key is this. Find the one that had the plus separating the two. When I put it back together, I know it's cosine from the fact that that said cosine and cosine. You'll notice on our sine one, it doesn't say that when we get there. I know that it's going to be the two angles, 70 and 40. And then the plus is what actually tells me what to put here. And in our formula, what does that actually say? Negative, right? It's actually your cosine of a difference formula. And I just get that from looking at my sheet. We're working backwards, okay? So when I subtract those, here's an indication that I did this correctly. 70 minus 40 is 30. Yes? Okay. Had I accidentally said 70 plus 40, what's 70 plus 40? 110. Guys, at this point, it should be on your unit circle, and it should look like a problem I can do. Can I do cosine of 110? Major indication that I picked the wrong sign, okay? This should be nice. There is a great indication that you are on the right track at this point. It should be a unit circle question. If we got something like this, that is an indication that we did something wrong because 110 is not on the unit circle and I wouldn't be able to do that problem. Okay? And then we just answer this. What is the cosine of 30 degrees? Square root of 3 over 2. Okay, so you've kind of seen both directions. They gave us the like matching part of it. We had to pick which formula that came from and put it back together, right? Or we had to pull it apart to be able to actually do this. There's your cosine formula. Let's move on to sine. What we do with sine is no different. Your formula is just slightly different. The biggest difference is you've kind of got mixed units here. So this is sine of a sum, and your formula goes sine of the first, cosine of the second, plus cosine of the first, sine of the second. You need to be a little bit more careful with this particular formula as you go to set it up, because order will matter a little bit. You have to get sine of each and you have to get cosine of each in there, okay? And then the same thing with our difference. It will go sine of the first, cosine of the second, minus cosine of the first, sine of the second. So this time the operation does not change. but you have mixed sine, cosine, cosine, sine. Okay. Questions so far? Does anyone still need this page? All right, let's try out our sine formula. This is your first time with radians. Please take good notes for yourself as to how to attack this. It says sine of 7 pi over 12. I need to split this into 2 unit circle numbers. Remember, our unit circle values would be pi over 3, pi over 4, pi over 6, pi over 2 are all options, okay? Pi over 12 is not an option, all right? So here's how we attack these problems in radians. What you're going to do is off to the side, I want you to make 2 fractions over 12. Don't put plus or minus between them yet, because you have the option. We can pick to add or subtract. And then you're going to think about numbers that will add up to 7. There are good numbers to pick and there are bad numbers to pick. There's a lot of numbers that add or subtract to give you 7. I'm going to start with a bad example. Don't put this, okay? And I'm going to tell you why it's a bad example. 2 numbers that add up to 7 would be like 6 plus 1. Yes? Okay? You would not pick 6 plus 1 because here's what I need to happen at this point. I need these fractions to simplify into something that will have a denominator of 3, 6, 4, or 2, which is anything that 12 is going to simplify to. 6 over 12 will simplify, but will 1 over 12 simplify? No. So that's a bad option. So we pick a different option. Now, we tend to think addition over subtraction, and that's fine because remember, they'll give us the same answer at the end. But if you decide to subtract, that's fine. For example, I could do 8 minus 1. Bad example because, well, 8 over 12 will simplify. Will 1 over 12 simplify? No. So you can do subtraction, but ultimately we need those 2 numbers to either add or subtract to 7 and also multiply with simplify with 12. Okay? So give me a good option. 3 and 4 would be a great option. 3 plus 4 is 7. 3 and 12 simplify, 4 and 12 simplify. Order does not matter. 3 plus 4, 7. 3 over 12 simplifies. 4 over 12 simplifies. So now what I'm going to do, come down here and write the simplified version of those 2 fractions. 3 and 12 are both divisible by 3. And this would simplify down to pi over 4. 4 and 12 are both divisible by 4. And this would simplify down to pi over 3. Questions? I know that was a long drawn out way of me talking about that. Once we get it down, it's going to go faster, I promise. So now we look. This is a sine of a sum. So we go to our sine of a sum formula. Our sine of a sum formula says this is equivalent to sine of the first angle, cosine of the second angle, plus cosine of the first angle, sine of the second angle. And now we're back to very similar to what we did with our cosine of a sum or cosine of a difference formulas, is I just find the value of each of those from my unit circle and simplify. Sine of pi over 4 is r squared root of 2 over 2. Hopefully the unit circle part is the part that's going to go a little faster for us at this point. Cosine of pi over 3 is 1/2. Cosine of pi over 4 is square root of 2 over 2. Sine of pi over 3 is square root of 3 over 2. And again, going to look very familiar at this point, or should look very familiar at this point. Multiplying straight across the top, straight across the bottom. And we get for this one square root of 2 plus square root of 6 over 4. Again, addition. We can switch the order of that. They're both positive. So if you had square root of 6 plus square root of 2 over 4, that's the same answer. How are we doing? Good? Okay. I know I showed this to you with a sine, but it does apply to cosine as well. It's anytime you have radians, tangent as well. Anytime you have radians, we're going to attack it this way. So let's try one more here. Cosine of 23 pi over 12. So you're going to start with 2 fractions over 12. We're going to go through our options of numbers that add or subtract to give us 23. And you can do add or subtract. For example, 1 plus 22 is 23. That's a bad one to pick because 1 over 12 does not simplify, right? Keep going through options until you find a pair that will simplify with the 12. Who's come up with a set? You said 15 and 8. So 15 plus 8 is 23. Does 15 over 12 simplify? Both divisible by 3, right? Does 8 over 12 simplify? Both divisible by 4. It works, okay? What were some other options that people came up with? No options? If you're struggling, just start with numbers. Again, we tend to think addition, and that is totally fine. I said that 1 plus 22, and that was a bad option because of the 1, right? 22 would simplify with 12, both divisible by 2. Okay, bad option. Great, move on to the next one. 2 plus 21, would that work? Actually, it does. 2 and 12 simplify. 21 and 12, both divisible by 3. That actually would be an okay option, okay? And keep going. So yeah, you could use that one. 3 plus 20, would 3 plus 20 be an okay option? Yeah, 3 and 12 simplify, 20 and 12 simplify. 4 plus 19, bad option. 4 and 12 work, 19 and 12 do not, right? So if you're struggling at the beginning here, just start writing 2 numbers that add up to the numerator and then assess, would those 2 work? We're going to go with 15 and 8. Okay? So now my next step is just simplify those fractions before we go pick our formula. 15 and 12 are both divisible by 3. And we get 5 pi over 4. 8 and 12 are both divisible by 4. And we get 2 pi over 3. Slow down on the simplifying part of it, okay? Sometimes that can catch us off a little bit. This is a cosine on the outside with a plus sign between our 2 fractions. So we now go find that formula that says cosine with a plus between the 2 angles, and we set that up. Your cosine formula says cosine of the first, cosine of the second, opposite operation, so minus sine of the first, sine of the second. Okay. New this time because we are finally looking at angles that are not falling in the first quadrant. And this is one that's going to catch a lot of people because we get moving too fast through these. Take a second. I'm going to erase this here. Take a second and think about those 2 angles. 5 pi over 4. 4 over 4 is a half a circle, right? So 5 over 4 would have dropped us into quadrant 3. That would be a picture of 5 pi over 4. Are we all okay with that? Remember, it's been a while, hasn't it? So why do I care? Think about your all students take calc. And now I've kind of thought through it for both of the times that it shows up in here. Also, 2 pi over 3. 3 over 3 would be half a circle. So 2 pi over 3 is a little short of that. It should have fallen into quadrant 2. And what that means about our answers as we move around this problem. Questions? Okay, so cosine of 5 pi over 4 in quadrant 3 is negative. My reference angle being pi over 4, cosine of pi over 4 is square root of 2 over 2. Negative because it was in quadrant 3. Cosine of 2 pi over 3. 2 pi over 3 is in quadrant 2. Cosine is negative, so this one again is going to be negative. Reference angle is pi over 3. Cosine of pi over 3 is 1/2. What I really want you to get out of this one is the signs. Are we all okay so far with my signs? Minus, and we move on to the next part of it. Sine of 5 pi over 4. 5 pi over 4 is in quadrant 3. Sine is negative in quadrant 3. Reference angle is pi over 4. Sine of pi over 4 is square root of 2 over 2. Again, negative because it's in quadrant 3. Sine of 2 pi over 3. 2 pi over 3 is in quadrant 2. Sine is positive in quadrant 2. So your last one that we're working on should actually be a positive value. Reference angle is pi over 3. Sine of pi over 3 is square root of 3 over 2. This is when the positive negatives, we got to slow down a little bit. Okay. First of all, a negative number times a negative number is positive. Multiply straight across the top, straight across the bottom, and we get square root of 2 over 4. Negative times a negative is positive. Over here, first of all, this would be a negative number times a positive, which would be negative. But if we're subtracting it, you see how it is a negative and a negative? So it's again going to look positive. Multiply straight across the top, straight across the bottom. And we get 2 positives this time. Good? Final answer, square root of 2 plus square root of 6 over 4. How are we doing? Good? Okay. So again, one more time working backwards, and this is working backwards with radians. Scanning through this problem, are we looking at a sine or are we looking at a cosine formula? Sine. How do I know that? Because it alternates. Yep, sine, cosine. That combo right there told me that it came from a sine. It is those two angles. And then this tells me what sign should go between those. And again, I consult my formula. If it had a plus between it, what was it in the parentheses? Also a plus. Yep. But if we are talking radians, I want to put these together. We need common denominator, right? So my common denominator is going to be 18. I'm going to multiply that first fraction by 2 to get my common denominator. Okay, 8 plus 7 is 15. This is, again, one of those getting to check that I'm on the right track moments. 18 is not on my unit circle, but 15 and 18 simplify, and it should simplify down to a 6, 4, 3, or 2. Okay, it should simplify down to a unit circle question. Just like earlier, we talked about if I accidentally added instead of subtracted, that it was an indication. Same thing here. This should simplify down to something on my unit circle. 15 and 8 are both divisible by 3. So if I simplify that fraction, 15 divided by 3 is 5. 18 divided by 3 is 6. That I can do, right? I can do the sine of 5 pi over 6. Anything over pi over 6 is on my unit circle. 5 pi over 6 would be just short of half a circle of 6 over 6. We are in quadrant 2. Sine is positive in quadrant 2. My reference angle is pi over 6. The sine of pi over 6. 1/2, right? Questions? So again, if at this point it doesn't simplify, something went wrong. And if it doesn't simplify down to unit circle, something went wrong. It will always take us to a unit circle question on these. Okay. Tangent. Tangent is different. Here are your sine, sum and difference formulas. Let's go back to our cheat sheet and put those onto our identities cheat sheet. So So it goes tangent of the first angle plus tangent of the second angle over 1 minus tangent of the first, tangent of the second. Similar for difference, but your signs flip. Tangent of the first minus tangent of the second over 1 plus tangent of the first, tangent of the second. Okay, and I'm going to warn you that with tangent, the better your number sense, the easier you can make tangent. So it is worth the time at the beginning to slow down, to make sure that you are picking strategically. Let me see here. For today, I'm going to give you guys just a unit circle on your table to look at. Probably should have done this earlier. Consult the unit circle that's on this sheet that I'm giving you. And remember, this is your word bank, right? Has all of your options that you would pick for angles or radians. Okay, we're going to start easy here. One of the things that I'm going to point out today is that I would strategically pick, when you break your fractions, to break it so that it will not have a pi over 6. We don't have to pick on this one because it's done for us, and we're going to ease our way into it. But later today, when you are picking, if it simplifies down to pi over 6, try a different option. You will be much happier with yourself. We're going to look at tomorrow why I'm saying that, but it's already enough work. Don't pick up pi over 6. Okay, so let's start with this one. Now, they already did part of the work for us. They broke it into 2 angles, and it is a sum. So we're just going to look at how do we then move from here into the formula and clean it all the way up. It takes a bit of work. Stay with me. Okay, your formula says tangent of the first plus tangent of the second over 1 minus tangent of the first times tangent of the second. Now that looks like a whole lot of things that we have to figure out from our unit circle. However, there's duplicates in there. So as I'm doing this, I can clean it up a little faster. So we have, start with your tangent of pi over 3. Tangent of pi over 3 actually shows up twice in here, right? So once I know what its value is, I can put it in both of these spots. This is again where we have to remind ourselves how to do tangent. Go to your method, and you might even want to just write out your 3 options. What is tangent of pi over 6? What is tangent of pi over 4? And what is tangent of pi over 3? Tangent of pi over 3 being square root of 3. Questions? Similarly, we have to find tangent of pi over 4. And it's in 2 spots. And once I know it, I put it in both of those spots, right? What is tangent of pi over 4? 1. Okay. This is where the work comes in a little bit. Then this is why I'm going to tell you, don't pick a pi over 6. And we'll get there. I will show you tomorrow why. But we are going to be asked to rationalize this, meaning I do not get to leave a radical in the bottom. So I'm going to take one step and just clean this up for a second, because 1 times this is just square root of 3. So how do I do this? We use the conjugate. We haven't done this in a while, but we did this first semester, and I cleaned up something that had a radical as in a binomial by multiplying by the conjugate. So we will multiply, and it is key that you use the opposite sign, right? So 1 plus the square root of 3. That is the entire key to this, is that I will multiply by the conjugate, 1 plus the square root of 3. Now again, you can FOIL in the bottom, or remember that it will be 1 first thing squared minus second thing squared. 1 squared is 1 minus, and this is where we got to be a little slower here, square root of 3 squared, 3. no radical left. First thing squared minus second thing squared. You have to FOIL on the top. There's not really any way around that. So let's go ahead and do that. Okay, reminder on radicals. Like terms, we can combine and we add the numbers in front. 1 square root of 3 plus 1 square root of 3 is 2 square root of 3. 3 plus 1 is 4. 1 minus 3 is negative 2. And then we can, they're all divisible by 2 or negative 2, right? Kind of what's going to make you see this better, I can break them both over the common denominator of negative 2, or I'm thinking about that I can divide every outside number by a negative 2. I'll just show the breaking part over which would be negative 1 square root of, oops, I changed that to a 2. Sorry, 3 minus 2. Or other order, negative 2 minus square root of 3. Questions? It's enough work. I would avoid the square root of pi over 6 because it will be more work, and it's worth the time to figure out a different pair that will add to the numerator that won't simplify to a 6 in the bottom. You want a pi over 3 or a pi over 4. Okay, let's look at one going the other direction. Tangent of 10 degrees plus tangent of 35 degrees over 1 minus tangent of 10, tangent of 35. This is your matching game. Go to your formula sheet. First of all, the way it is set up tells me that this is a tangent of a sum or a difference. I know the two numbers are 10 and 35, and I have to match it to figure out if it's a plus or a minus between that 10 and 35. Should it be 10 plus 35 or 10 minus 35? Plus. Key is, again, look at this. And, as always, if it doesn't end up being a unit circle number, something went wrong, okay? Well, 10 plus 35 is 45, which is a great indication that we're on the right track because that's a unit circle number. Tangent of 45 degrees is 1. Questions? Okay. Your assignment tonight is a worksheet. And as I glance at the worksheet, there is one problem that we're going to, two problems that we're going to look at a little bit together just to help out. You're welcome. Yes, if you would like to take a picture of that unit circle, you cannot take that with you. I need it to stay on the table, but you are absolutely welcome to take a picture of that unit circle for your word bank. Let's jump to number 3 and number 6 because they're tangent problems. Okay, I said avoid something that's going to simplify down to a pi over 6. That's the same thing as a 30-degree reference angle. So we also want to avoid tangent of 30 degrees or tangent of pi over 6. And it's anything that has that reference angle. So not only 30 degrees, but like 150, 210, 330 would be all of your unit circle numbers. I would not pick those. So what am I talking about? If we were to go to number 3 on your worksheet, that is tangent of 165. And I'm trying to split 165 into two numbers that are added or subtracted from my unit circle, I would not use those numbers. I would not use 30. I would not use 150. I would not use 210. And I would not use 330. Questions? Pick other numbers. There are lots of other numbers on your unit circle that you can pick from. Don't pick these. it'll be too much work, and we'll talk about that tomorrow. Same thing on number 6 is you're looking at tangent of 7 pi over 12. Be cautious as you pick those. So for example, 9 minus 2 does add up to 7, subtract to 7. But this right here would simplify into pi over 6, and we don't want that to happen. So I would try a different set of numbers that add to 7. Okay, don't get a pi over 6, don't get a 30-degree reference angle, and you will be a lot happier with yourself. Tomorrow, we review. Yeah. Yeah, tomorrow.